Okay, so now we go to the question 6, okay, which okay is the power factor improvement, okay, for question 5. Okay, so in this question, okay, so you have to improve the low power factor, okay, as what you got, okay, or what you found in question 5. Okay, so you are required to design a simple power factor correction circuit. Okay, so the new target of the power factor is 0.9 lagging. So you also have to determine the value of capacitance in order to improve the power factor to 0.9 lagging. Okay, so you also have to draw the new circuits with the power factor correction and the new value, okay, of the supply current after you did the power factor correction for the respective, okay, figure. Okay, so now, okay, as what we have discussed, okay, before this, okay, so this is the general important step, okay, that you should taken, okay, in order to do the power factor improvement. Okay, so for these questions, okay, so you need to improve the power factor to 0.9 lagging. Okay, and then the first step, okay, so you have to find the QO for the all power factor. Okay, so the all power factor is 0.46, right? Okay, so now, okay, so you have the new, sorry, the all Q, K is the Q load plus with Q M or Q motor. Okay, so the total of the Q, okay, the Q all is equivalent to 2000, okay, 643.6 plus 720.5, which give you 3364.1 bar. Okay, so this is the, okay, the all Q, okay, or the all rectifier before you do the power factor improvement. Okay, so the next step, find the Q new, okay, for the given, okay, new power factor. So the new power factor that you want to correct is 0.9. Okay, so from this power factor, so you can get the new angle, right, which is 35.8 degree. So this will give you, okay, the new Q, okay, from this formula PT tangent theta. Okay, so the P, okay, from the previous, okay, before, okay, you did the improvement power factor, okay, so which is equivalent to P load plus with your PM, okay, that give you 1752.1 watts, okay, times with tangent, okay, your new power factor in angle is 25.8 degree. So this gives you the new reactive power at 847 bar. Okay, so in step 3, you have to find the deviation of the Q new and Q old to get the QC. Okay, so the Q old is 3364.1. You subtract with your new Q, which is 847 per, so which give you 2517.1 bar. Right? So using this kind of formula, in order to find the capacitor, okay, based on the deviation of the Q, okay, delta Q is equivalent to V squared divided by XC, or also, okay, equivalent to V squared omega C, okay. So you can find the XC, okay, from V squared divided by Q, C, or the delta Q, okay. V squared divided by delta Q, okay, which is 240 squared divided by 2517.1, give you 22.9 ohm for your XC. You know that your XC is equivalent, okay, to 1 over omega C, which also equivalent to 1 over 2 pi Fc. So thus you can get your capacitor, new capacitor value for this new XC, okay, is equivalent to 139 microfarad. So this is the required capacitor that you must put in parallel in order to improve the power factor to 0.1 lagging. Okay, so draw the new circuit to the power factor correction. Okay, so you have to insert, okay, the new capacitor in parallel, okay, which, okay, you found previously at 139 microfarad in parallel with your, okay, motor and also your coil load. Okay, and then, okay, the next question is to find the supply current after you do the power factor correction. So, okay, from the equation P is equal to VI cos theta. So you can find your I now, okay, with the given of P, because your P is remaining the same, okay, and the V, okay, you put the V as 240, okay, as given previously, and the new power factor is 0.9. So you have, okay, the new supply current is 8.1 ampere. Okay, from your observation, okay, so your I new or your I supply current now is decreasing or decrease, okay, from higher to lower current when you do the power factor correction.